Thermodynamics in Biosystem, Module 2, Basic Concept of Thermodynamics, Segment 5, Pressure. With me, Yusuf from School of Life Sciences and Technology, Institut Teknologi Bandung. Previously, we have discussed about system and its properties, state and equilibrium, processes and cycles, as well as temperature. In this segment, we will discuss about pressure. Pressure can be defined as a normal force exerted by a fluid per unit area, and it is a scalar quantity. Since pressure is defined as force per unit area, it has the unit of newtons per square meter, which is called as Pascal. The pressure unit Pascal is too small for most pressures encountered in practice, therefore its multiples kilopascal and megapascal are commonly used. Three other pressure units commonly used in practice, especially in Europe, are bar, standard atmosphere, and kilogram force per square centimeter. Pressure is also used on solid surfaces as synonymous with normal stress, which is the force acting perpendicular to the surface per unit area. The actual pressure at a given position is called the absolute pressure, and it is measured relative to absolute vacuum. Gauge pressure is the difference between the absolute pressure and the local atmospheric pressure as shown in equation 10. The gauge pressure can be positive or negative, but pressures below atmospheric pressure are sometimes called as vacuum pressures and are measured by vacuum gauges that indicate the difference between the atmospheric pressure and the absolute pressure as shown in equation 11. Variation of pressure with depth. Pressure in a fluid at rest does not change in the horizontal direction. However, this is not the case in the vertical direction in a gravity field. Pressure in a fluid increases with depth because more fluid rests on layer, and the effect of this extra weight on a deeper layer is balanced by an increase in pressure. To obtain a relation for the variation of pressure with depth, consider a rectangular fluid element in equilibrium, as shown in the figure. Assuming the density of the fluid to be constant, a force balance in the vertical z direction can be expressed as below. Dividing by delta x and delta y and rearranging the equation yields equation 12. Thus, we conclude that the pressure difference between 2 points in a constant density fluid is proportional to the vertical distance delta z between the points and the density of the fluid. An easier equation to remember and apply between any 2 points in the same fluid under hydrostatic conditions can be expressed by equation 13, where below refers to the point at lower elevation and above refers to the point at higher elevation. For a given fluid, the vertical distance delta z is sometimes used as a measure of pressure, and it is called as pressure head. Pressure in a fluid at rest is independent of the shape or cross-section of the container. It changes with the vertical distance but remains constant in other directions. Therefore, the pressure is the same at all points on a horizontal plane in a given fluid. A consequence of the pressure in a fluid remaining constant in the horizontal direction is that the pressure applied to a confined fluid increases the pressure throughout by the same amount, which is known as the Pascal's law. The force applied by a fluid is also proportional to the surface area as shown by equation 14. Pressure measurement devices. Barometer. Atmospheric pressure is measured by a device called a barometer as shown in the left figure. The atmospheric pressure can be determined by writing a force balance in the vertical direction as shown in equation 15. A manometer is commonly used to measure small and moderate pressure differences. A manometer consists of a glass or plastic U-tube containing one or more fluids such as mercury, water, alcohol, or oil, as shown in the middle figure, and the pressure can be calculated using equation 16. Other pressure measurement devices. Another type of commonly used mechanical pressure measurement device is the Bourdon tube. named after the French engineer and inventor Eugene Bourdon. Modern pressure sensors called pressure transducer use various techniques to convert the pressure effect to an electrical effect, such as a change in voltage, resistance, or capacitance. Piezoelectric transducers, also called solid-state pressure transducers, work on the principle that an electric potential is generated in a crystalline substance when it is subjected to mechanical pressure. Another type of mechanical pressure gauge, called a deadweight tester, is used primarily for calibration and can measure extremely high pressures. In the next segment, we will discuss about problem-solving technique. Until then, I am Yusuf from Institut Teknologi Bandung.